How you doing, Ms. Stewart?
I'm great. How are you, Mr.
Good.
Haas?
I'm fine. We're going to do a problem involving related rates.
Have fun.
Yeah. So this is a right triangle, and we're given, this is all information we're given that the ratio of the two sides, the two legs of the right triangle, are 3 to 4, right? So it's a ratio of 3, 4, 5 right triangle, obviously.
Ah,
right?
nice. Okay.
Okay. So, I mean, to express this ratio, I just wrote 3x with 4x.
That makes sense.
And the triangle is expanding, as they often do.
It's so crazy how
I don't know
shapes
how
do that
but
all
in
the
related
time.
rates, apparently they expand, gives expanding triangles. The triangle is expanding such that this ratio stays the same. I mean, as it gets bigger, obviously, it's still going to be the same ratio, 3x to 4x.
So you're going to have a similar triangle as
yes,
it
it will
gets
be.
bigger. How cool.
Sure, yeah. And you're asked to find dA dt. Of course, this is the rate of change of area with respect to time. How is the area of this triangle changing when the perimeter is 120 inches, given that the perimeter is expanding, the rate of change of the perimeter is expanding at 24 inches per minute.
Very nice. Okay, so you know this is expanding.
Yes.
You're asked to find the rate at which the area is changing at the instant
Yes.
when the perimeter is 120
At that
inches,
instant.
given that the perimeter is changing at a constant rate of 24 inches
So
per minute.
let's start out by writing an equation that relates what it is that we're trying to find here with this triangle.
Yeah.
Right? I'm trying to find the rate of change of area, so obviously I need an area equation. The area of a triangle is 1/2 base times height.
Very nice.
I'm just going to write it as 1/2 base times height.
Very good.
You buying this?
I am.
I think I can simplify that a
I
little
think
bit.
you can.
All right, so I will write that as area equals 1/2 times 4 is 2x times 3x is 6x squared.
Very nice.
And obviously this is a related rate problem. I want to know how this is changing, how area is changing, so I will take the derivative of this. But if I think ahead a little bit, I can see that when I take the derivative of this side, I'm going to end up with 12x dx dt. I don't really have anything about dx dt. I do have information about perimeter, and I do have information about how the perimeter is changing. So I'm wondering if I can write this x in terms of the perimeter.
Ooh, that is
Can I
such
do
a
that?
clever idea.
That might be helpful, and then I can just express this area in terms of perimeter. When I take the derivative, I'll have everything that I need.
I like that.
So
Let's
I'm gonna
try
do
that.
So I do know that the perimeter of this triangle is 3x plus 4x, and I guess I already said that I know this ratio is going to be 3, 4, 5, right? Triangle, right? 3 squared plus 4 squared. Do I have to do this, or you got it?
You don't. We
3
just
squared
know
plus
3,
4
4, 5
plus 5 squared.
triangle.
You've
Yeah.
probably seen that before.
Yeah.
Right. So the perimeter of my triangle I can express as 3x plus 4x plus 5x, also known as,
12x.
thank you very much, 12x. Yeah, right.
Very good.
And I would like to solve for x, so perhaps I will divide both sides by 12,
That
or
sounds-
multiply by 1/12.
Very good.
1/12.
Very
You
nice.
still see that down there?
Oh, yeah.
So 1/12
P.
p equals x.
Good.
Divide that.
Yeah.
All right. I have x right here. I know that x is the same thing as 1/12 p, which I'm going to stick right in there.
Yeah.
So I'm going to write this as area equals 6 times 1/12. Oops. I'm messing up here, Miss Stewart.
That's fine. You keep forgetting your x
1/12 p
or your p.
squared.
Yeah, it's like you took two equations and smushed them together, like, you
You've done
know,
this since
systems of
second grade,
equations.
probably. Yes, systems of equations, right? And the reason that I did this is because everything else, I mean, I knew what dp dt was, I knew what, I know what p is, so I made my equation in terms of area and perimeter, and I'm going to simplify this a little bit. 1/12 p squared, 1/12 p times 1/12 p is 1 over 12 squared is 144 p
Right.
squared, so where can I continue this?
You
I
can
continue right
continue
away? I'm gonna
down
go right
below.
over here.
Okay, that
so
looks
area
good.
equals 6 times 1 over, that's 6 times 1 over 144 p squared.
Very nice. I think we can simplify that.
Maybe I'll just stick the 6 on top. How about if I did that?
Yeah.
Would that work for you?
Sure.
All right. Now I'm going to take the derivative. This is the exciting part. The derivative of area is 1 dA dt.
Very nice.
The derivative, of course, of 6 over 144p squared is 12 over 144p
dp dt.
I think I have everything I need.
Yeah, so this is so great. You thought ahead
I did.
and you thought, okay, all of your information is in terms of perimeter. Let's write my equation in terms of perimeter, and now you're ready to
This,
go.
of course, I can. This is 1 over 12.
Yeah.
P, I'm told, is 120 at this moment in time, and the perimeter is increasing at 24 inches per minute. And this is going to come out as, well, I think I
Nicely.
can see this, yeah, very nicely. I can
Yeah.
see because 2 over 12, sorry, 24 over 12 is 2 times 120, it's going to be 240.
240.
The ADT is 240, and if I wanted to put units, of course, this is area. So this must be how the area is changing. It must be square inches per minute.
Very nice. That is lovely.
Yeah, thanks, Ms. Stewart.
Now, there is another way to do this. Should I do it another
That would
way?
be great.
And
Love
then
to see
students
that.
can decide which way they like best, and they can do whatever they like best.
Sounds good.
Okay. Let's try this problem another way. And again, you might like Mr. Haas's method better. You might like my way better. I mean, it's not my way or Mr. Haas's way. It's,
Wait a minute, you didn't invent this way, Ms. Stewart?
All right.
But you're related to Newton, though, aren't you?
So I am,
Yeah,
and
all right.
you're related to Leibniz.
Right.
You look just like him,
I was, yes.
especially with the big wig.
Yes, yes.
All right.
Okay.
Same setup. I'm looking for dA dt, same problem, so I'm going to set up my equation. Area is 1/2 base times height. So can I just cut to the chase since you already did that part?
Area is 1/2 base times height.
So
Right.
it's 1/2
Got
3x times 4x, 1/2 12x squared.
Terrific.
Okay, now, Mr. Haas, what you did at this point is you looked at this and you said to yourself, this is in terms of x, and all my information is in terms of p, so let me do some algebra. What I'm going to do instead is just dive in and do the calculus,
Sure.
and have the calculus tell me what I need. So, I'm going to take the derivative of both sides with respect to time. The derivative of a is 1 times dA dt. The derivative of 6x squared is 2 times 6, which is 12x dx dt. Okay, so now I know to find what I'm looking for, I need to find an x somehow, and I need to find a dx dt. These are my missing ingredients. So I'm just going to go and look for those missing ingredients. So I'm going to come on over here and say, okay, I know my perimeter is 120, so let's use that information to find my x. So perimeter is 3x plus 4x plus 5x, and I know that equals 120. Oh, okay, I can solve for x. This gives me 12x, which is 120. That gives me x equals 10. Bingo, I found one of my missing ingredients. Let's pop that in there. 10. Okay, now let me find my next missing ingredient. My next missing ingredient is dx dt. All right, well that might be a little more complicated because I have to do a little calculus to find that. So now I want to think, okay, dx dt, I'm going to need information for that, and I think dp dt is going to help me find it. So if I go back to my perimeter and say, okay, my perimeter is 12x, right? And I say, oh, well that equals my perimeter. Are you following me here?
I'm with you, yeah.
To get a dx dt, I need to take the derivative of this. So let's see, the derivative of 12x is 12 dx dt. Derivative of p is 1 times dp dt. Ah!
Oh, yeah.
Okay, so now I know dp dt is 24. So I'm going to say 12 times dx dt, are you still getting me there?
Yeah.
Equals my 24. If I divide by 12, that's going to get me that second missing ingredient. My dx dt has to be 2
Yeah.
inches per minute. Okay, so that was the bit of information I needed here. So I put that in, and now I'm ready to say, oh, it's 12 times 10 times 2, and that gives me my 240 square inches per minute.
Well, that is beautiful, Ms. Stewart.
Yeah, so a different approach. So for this one, I just did my calculus. The calculus let me know what was missing. I had 2 missing ingredients. I just went and found those missing ingredients by setting up different equations and, when
So,
necessary, doing the calculus.
Will there be times when like only one of these ways work, or?
They will, I think they will both always work, but there are times when doing it the algebra way, the way that you modeled, is so much easier. And there are times when doing it this way might be easier. So I think it's really just a journey that every student needs to go on to discover what works for them. But it's always nice to have lots of different strategies to with that.
Thanks, Ms. Stewart.
Thank
Very
you,
good.
Mr. Haas.